We're going to start on chapter section 3, talking about population proportions. Okay, so this is confidence intervals that are in terms of proportions or percentages. And probably some of the biggest things that are going to let you know on this is when you're dealing with a proportion is because the underlying distribution is going to be a binomial distribution. Okay? And there is not going to be any a mean or average. Okay. Right. And P prime is going to be the same as P hat, and that's going to be on the next page. But P prime is probability that an event is going to happen. It's just the proportion of it, because a proportion is just a fraction or a ratio. So it's the event desired outcome occurring out of the total sample. All right. Now up here, remember they can't use this unless the sample size times the probability of success is greater than 5, and the size times the probability of failure is greater than 5. Okay, so we have to make sure that those qualifiers are met first. All right, so we're going to go through example 8.10. Okay, this is on page 457. So suppose that a market research firm has hired to estimate the probability of adults living in a large city who have cell phones. 500 are randomly selected, and they're going to answer the question whether or not they have a cell phone. Of the 500 people surveyed, 421 respond yes, they own a cell phone. We want to do a 95% confidence level to compute the confidence interval and find the true proportion for adults residing in the city who have cell phones. All right, so before we can do this, we want to make sure that it meets the qualifying parts. So we're going to do n times the probability of success. That has to be greater than 5, which that is. And then n times the probability of failure, and that has to be greater than 5, which this is. Okay? So we know that it meets that. And this is also binomial. We have a set number of trials, and either they're going to respond yes or no, and each event is independent of the other. So it's binomial, it meets all the qualifications, and the n times p and n times q is greater than 5. All right, so we're going to go to our statistics and then go over to tests, and this one's going to be a proportion. Okay, so we want to make sure we're selecting this one. And I'm in here, we're going to do 421 said you have a cell phone out of 500 people. And we want to have confidence level 95%, so 5. All right, so now we have our confidence interval, and this is going to be 1 and 874 if we round to 3 places. All right, so talk about our interpretation. We estimate with a 95% confidence that between 81 that comes here, and 87.4%, that's here, of all adults residents in the city have cell phones. Okay. So that's the interpretation of this information. All right, so now we're going to go to page 460 in the packet. Okay. On page 460, plus confidence interval for proportions. All right, so this we only use when we want S to 90% confidence level, and our sample size has to be at least 10. And if that's the case, then we're going to pretend that we have additional observations. 2 of those are going to be successes, and 2 of them are going to be failures. Okay, this allows an adjustment and increase the number of our sample size to counteract any flaws that can be found in our distributions. Okay, so this is the plus 4. Right. So we're going to look at example 8.12. This is on the bottom of page 460. A random sample of 25 statistics students were asked, have you smoked a cigarette in the past week? 6 students reported smoking within the past week. We're going to use that plus 4 method to find the 95% confidence interval of the true proportion. All right, so we know that this is going to be binomial because we have a set number of trials, and they either smoked or did not smoke, and each person is independent. Okay. And then if we check our number times our probability, so n times p is greater than 5, and n times q is also greater than 5. So we're going to use this plus 4 So instead of having 25 in our sample, we're going to say there are 29. And instead of 6 reporting that they've smoked, we're going to use 8. Alright, so we're going to go into the stats and to our tests, and we're going to do a proportion. So this is option A. And instead of putting in 6, we're going to use 8 because we're using that +4 model. Okay? And then instead of 25, we're going to have 29. And our confidence level, we still want to do a 95% confidence interval. Alright, so we can say that the proportion, the true proportion, we can say with 95% confidence that the true proportion lies between 0.11319 and 0.43853 of the number of students who at this college who smoked. Alright, and also in earlier sessions we talked about the EBM, which is the error bound for means, and now for this one we have the EBP, which is the same thing, but it's just for proportions instead of means. I'll leave you with a reminder at the end of every packet. You have some keys and then a review of the chapter. So take a minute to go through those, double check to see if you're understanding all of the options that are there. Okay. And here's the BM, this is the EB. Wish you guys good luck, and we'll see you later.